Welcome back. This is going to be part 3 of the Ecology Tools videos. And now that we have some information about the abiotic environment, we might want to start to characterize the organisms that are living here, the biological community in this ecosystem. And probably the easiest to characterize would be the plant community, the producers, right? Because they aren't moving around. And we have some different tools that we can use to help us figure out how many plants are here and what species are here and how common are these different plants and how much biomass do some of these plants have. So the first thing that we might want to do is to characterize the plant community, do a vegetation survey. And we might have a couple of different tools depending on the type of vegetation that we're looking at. If we wanted to figure out what sort of herbaceous plants, these small plants that are low to the ground, we would want to sample inside a fixed area and try and count up all the different plants that we have and tally them and maybe estimate which ones are covering more of the area than others. And so a great tool for that is actually a hula hoop. You can measure the diameter and you can use some math to calculate the area of this circle. And we've actually done that here. And this hoop is, let's see, it's a little bit more, like 0.65 meters in diameter, which means that it has an area of about 1/3 of a square meter. And when you're using these hula hoops, you want to sample a random area. You don't want to say, oh, there's a lot of that over there, let's put this over there. No, you want to make it random. And a great way to do that is to maybe spin around a couple times with your eyes closed. And then just toss the hula hoop out there, right? And wherever it lands, that's your sampling area. So ecologists do this all the time. If you see someone out in the woods with a hula hoop that's tossing it and chasing it, chances are they're doing some biology. All right, so let's say we're interested in larger plants that are that the hula hoop is not going to fit around. So shrubs or trees, that we might need to scale up our measurement and look at a larger area. And there's different ways that we could do this. We could use kind of another circular plot measuring area. And basically what you can do is make kind of your own compass. So you could take a piece of rope, and we've actually pre-measured these pieces of rope so that they are exactly 5.64 meters long. And again, doing some math, we figure out that this makes an area between the center and the edge of the rope. If we take it around, that is 100 meters squared, or 100 square meters. So you could put this in an anchor point in the ground and take the rope and measure out. And if there's a plant inside that area, you would count it, and if it's not, then you wouldn't. And you would know the number of plants per 100 meters squared, or per 100 square meters. And again, you'd want to choose a random point to start with, and you might need to thread this rope around some of the larger trees a little carefully. So this might take a little bit longer to do, and if you wanted to measure every last plant in that size area, you could be there for a while. Now, how do you know what plants are in the area? Well, that is where field guides come in. So if you're not well versed in botany and you aren't quite sure what the plants are, you could consult a field guide, which hopefully is going to have a key inside of it that you could use to figure out what the plants are. Depending on where you're sampling, if you're allowed to collect plants, you could collect specimens, bring them back, and then talk to a botanist. But if you aren't allowed to collect them, you could maybe take pictures, look at the keys, try and get a tentative identification, and then maybe bring those to an expert later on. All right, the last thing is maybe let's say we know there's some trees in this area here, but not all these trees are the same, right? Some of them are really small, and actually this one looks, well, maybe not quite dead. And then there's one that's further in the distance that is bigger and older, we would presume. How can we quantify that? We can't just say, oh, there's a small tree, a big tree of whatever species. We would want to quantify that a little bit more. And if we're looking at trees, two of the more important measurements that we could take are the height and the diameter of the stem or the trunk or the bole, B-O-L-E, of the tree. So we have some tools to do that as well. And I will pull those out. So for measuring tree height, you could get really fancy and use a clinometer, which those are, I don't know, 100, 150, 200 bucks. Or you could use this little simple device, or you could build something very similar and maybe use your cell phone, like the internal level in your cell phone. So this is a tangent height gauge, and basically it works by, this is set at a 45-degree angle, and based on trigonometry we know that if that's the angle, the distance, the horizontal distance is the same as the vertical distance, right? So what you can do is use this little peep sight to look up at a tree while keeping the device level, and then move your feet back and forth until you find, oh, here's how far away I am when the tree is at a 45-degree angle, or when my line of sight to the top of the tree is at a 45-degree angle. And then you measure that distance and then add the height to your eye, and that will give you the height of the tree. So I'm going to do this now. I'm actually going to pause the video because I don't know exactly where I'm supposed to be set up to do this. But I'll do that and show you how we would measure the tree and maybe take some data. And I'm going to go for the tree that's not the scrawny little one right here, but the one behind it. That one. So, okay, so I've determined where I need to be to sight to the top of the tree at a 45-degree angle, and it's actually not too far from where we started. So just looking over this way and making sure that the level is level, I can see that the top of the tree is right through the sights. So this is the point I need to be. I need to measure that distance with a meter tape, and then also measure my height, and then we'll have our tree height. So I'm going to get the meter tape out. And do some measuring. All right, so got our meter tape here, and I'm going to get back into the position where I can see that tree, top of the tree through the sights. Keeping this level right about here. Okay, and then we measure the distance to our eye, which looks like 8.200 meters. We'll record that data. Meters. And then we need to add the height of our eye, which we would meter marking. Going up to our eye. It looks like about 1.78 meters. 1.78 meters plus 8.2 gives us 9.98 meters tall. So that tree over there is about 10 meters tall. All right, so now we've got the tree height, but how can we figure out how big around it is? What's its diameter, and how do we do that in a standardized way? So I'm gonna pause the video and we'll get up close to that tree and continue. All right, we're back and we're up close to that tree, and now we're gonna try and measure the diameter of this tree. If you know anything about trees, you know that they aren't uniform in diameter from the base to the top, right? They get smaller, so it's kind of like a cone. Well, where exactly should we measure that cone to standardize the diameter? And there's some confusion about this. What most foresters have settled on is the diameter at breast height, or DBH. But there's a slight problem with that because humans vary in size, right? So we are going to define breast height at either, depending on where you are, it's either 1.3 or 1.4 meters. We're going to use the international standard, which is 1.3 meters. But just bear in mind that if you use 1.4, those diameters are going to be a little bit smaller. So this is a DBH tape. It's got a hook at one end that you can hook around the trunk of the tree or the bole of the tree. And one side of this is just kind of graduated in centimeters. And then the other side, it says diameter in centimeters and millimeters. So when we wrap this around the tree, it's already accounted for pi and is going to give us the reading directly. So first we need to see how high up on this tree we need to measure it. And I'm going to make sure that the zero mark is on the ground. Okay. And then we'll go up to 1.3 meters, which is right there. And keeping that spot marked, we'll wind up the tape a little bit. And then we can put the hook in right there. And ooh, this one's a tricky one because there's an extra branch that comes out right about there. So I'm just, for now, going to measure all the way around it. This is maybe a little bit of a cheat. Sometimes if you encounter a problem where the tree kind of bumps out, you'd want to go up 10 centimeters or so. Do this, and when we do this, we find that the diameter is 25.7 centimeters. So we would record that data, and then also maybe make a note that there was a bump in the way. So maybe 25.7 centimeters at 1.3 meters high. Maybe we'll go up a little bit higher and try and avoid that if we can. I think we can. So I could have picked a simple tree, right? Well, nature isn't simple. So, okay, so once again, the tape on the ground, measure up. In here, let's go up to 1.4 meters and see if that helps us. So 1.4 meters is right there. Oh yeah, that'll work a lot better. Again, I'm going to go around the other way so it's reading right side up this time. We can read that, and there it's now saying 19.8 centimeters. So we'll record that as well. 19.8 centimeters at 1.4 meters high. But then we would also want to take it into account the other stem that is coming out there. So we'd want to measure the diameter of that at the same height and then add those together. So that's how you account for like a tree that splits in two and then both trunks go up. You can just add those diameters. All right, so that is the Ecology Tools videos. Hopefully these have been interesting, and I wish you all could be out here with me, but we got to stay safe first. So hope you're all doing okay, and take care.